Hello. In this lecture, I try to explain the normal probability distribution function, and this is the third part of the probability distribution functions. And you can find the other videos or lectures in the description box. Okay, you can find the links there. Normal probability distribution, perhaps the most important probability distribution used to describe a continuous random variable, is the normal probability distribution. It has a wide practical application. It has a wide practical application such as the height and weights of people, IQ score, amount of rainfalls, and so on. So random variable to have the normal probability distribution, which is a continuous probability distribution, random variable must be a continuous variable. It should not be a discrete variable. It should be continuous variable, such as the rainfall, such as the height and the weights of the people, and the IQ score of students. The form or shape of the normal probability density function is the bell-shaped curve. It is like a bell. But one thing you can look here that this is the normal distribution curve. The ending tail never touches the x-axis. Okay, it is the theoretical understanding. This line should not touch the x-axis. This line should not touch the x-axis. This is the normal distribution curve. And the width of the normal distribution curve is nothing but the standard deviation. Is nothing but the standard deviation. Standard deviation determines the width of the probability density function. Okay, larger values of standard deviation, larger values of the standard deviation result in wider, flatter curves. Wider and flatter curves showing more dispersion in the random variable. Showing more dispersion in the random variable. When there are more dispersion in the random variables such as rainfall, such as the height or weight of people, so there should be there should be more dispersion when standard deviation is very high. And mean, there is mean, and mean is the highest point on the curve. Highest point on the curve. Look at this. Highest point on the curve. Okay. So this is the role of mean and standard deviation in the normal distribution curve. The normal probability density function is this: 1 by root 2 pi sigma e to the power minus x minus mu whole square divided by 2 sigma square. Here pi is equal to 3.14159 and e is equal to 2.71828. Okay, this is the normal probability density function. You should remember this. This is the normal probability density function. Now, there are three normal distribution curves, 1, 2, and 3, with different means. If you have a closer look, you can find that means are different. Here mean is minus 45. Here mean is 12. Here mean is 55. This is for this curve, the highest point on the normal curve is minus 45, and highest point of this normal curve is 12, and highest point on the normal curve occurs at the mean, that is 55. Occurs at the mean, that is 55. So this is the pictorial presentation of the normal distribution curves with different means but same standard deviation. Now, here are also the three normal distribution curves, but here mean is the same. The highest point on the normal curve is the same, that is the mean is 7. But the standard deviation, that is the width of the probability density function, is different. When it is 4, its shapes look like this. Less wider, okay? Dispersion is less. Dispersion in the random variable is less. When standard deviation is 9, it is wider. Look, it is wider, and it is flatter comparative to this normal distribution curve, where standard deviation is 4. Where standard deviation is 9, it is wider, it is flatter. Dispersion in the random variable is high. Now, when standard deviation is 20, more flatter is the curve, more wider is the curve, more dispersion in the random variable. Okay. So this is the graphical presentation of the normal distribution curves with the same mean, but the different standard deviations. This is the normal distribution curve. Also, it is a normal distribution curve with standard deviation 9. Okay. Now, it is a practical example, and score for class 12 students in statistics with mean 74.56 and standard deviation 11.53 can be presented with a normal distribution curve. This is the marks of 25 students in statistics. Okay, 58, 75, 78. These are the marks, and this is the density, and it is derived. The densities corresponding to the numbers obtained by the students are derived in Excel, and you can derive it with the help of mean and standard deviation. And if you plot it, then you can get a normal distribution curve, which has a mean 74.56. That is the highest point on the normal curve, and the standard deviation is 11.53. That is the dispersion, that is the width of the probability density function. Okay, so this is the normal distribution. This is the normal distribution curve. This is the normal distribution function. So I hope you understand what is the normal distribution, and how it is, how does it look. And so I hope you have understood this lecture, and thank you for enjoying this lecture.